neural networks are all about prediction, but now we're going to look at causality. Yeah, so in economics we're often interested in causality because we want to know whether a certain policy causes a certain effect. So the main point of this part of the lectures is not so much the instrumental variable estimation, or how you do IV using stats models. The main point is that you can actually test your ideas on how to estimate something by first generating your own data and then use your estimation method on these data. So in this way you can check whether your estimation technique that you would like to use on real data actually works. Yeah, so in particular, does the estimation technique recover the parameters that you put in yourself when you were generating the data? So we're going to illustrate this method of first generating our own data and then estimating to see whether we get the right effects, using an example where we are interested in the effect of education on the wage that you earn in a job. Yeah, so we're going to have a couple of variables. We're going to have variable E, which is education. We have a variable W, which is the wage. Then we have a variable Q, which gives us exogenous variation in education. So the notebook explains a bit of the background of these variables and how they are generated actually in a real paper. And then we have a variable U, which sort of measures the individual's motivation to succeed in both education and in the workplace. So first let's generate our data. So we're going to generate a number of observations, and let's say that we're going to work with 200 observations here. So that will be the number of observations that is actually in our data set. I'm going to introduce a constant that we're going to have later on, so that's going to be alpha w. I'm going to set that equal to 1. I'm going to have alpha EW, which I'm going to set equal to 0, so that means that in the data that I'm generating, education will not have any effect on the wage rate that you earn. And the question now is, can our estimation technique recover that value of 0? I have another constant, alpha E, which I also set equal to 1. And we're going to have an effect beta QE, so that's the effect of the exogenous variation in education, which I set equal to 2. So now we're going to generate our data. So first, the exogenous variation. It's going to be a random variable, and I'm going to assume it's a uniformly distributed variable. As explained in the notebook, you can think of Q as the day of your birth, and we're assuming here that births are distributed uniformly across the year. That's not completely correct, but it's correct enough. So I need number of observations of this variable, so that's many draws we're going to get out of the uniform distribution. We have our motivation variable, which we're going to assume is normally distributed. Yes, I'm not specifying a mu and a sigma for the normal distribution, but basically means that it's a standard normal distribution. So we also, again, we have number of observations. So now I'm going to specify the years of education that you're going to have. So that's alpha E, so that's a constant, plus beta QE times Q. So that's your exogenous variation. So that basically comes from your birth month in a given year. So then we get your motivation. So if you're more motivated, you're going to have more years of education. And again, we're going to have some error term here. So it's going to be tf random dot normal. And also here we have number of observations. Then we're going to specify your wage, the wage that you're going to earn. So that's given by constant. This alpha W. It's going to be beta EW times the years of education that you've had. So remember, we assumed here that this coefficient is actually equal to 0. So that's the coefficient we want to recover later on. Plus U. So here again, your motivation affects the wage that you're going to earn. If you're more motivated in the workplace, you're probably going to do better, and therefore you're going to earn a higher wage and expectation. But there's also going to be some noise here, so random, normal, number of observations. And I'm going to put all these variables in a data frame, so we're going to use pandas data frame. So in the data frame, I'm going to have a variable q, so that's the column name, and it's going to be, the values are going to be equal to the variable q that I just defined. I have another column, oops, that should be a comma. The next column is education, which equals r vector education, e, and it's going to be a column w, the wage rate, and that's going to be w. So let's see whether we didn't make any mistakes. No, we didn't get any errors, so now we can actually run our regression. So I'm using stats models here. I'm using OLS. The regression is W on E. The constant will be added automatically. The data is going to be the one from our data frame df that we just defined. And I'm going to fit this. And now we're going to print from results the summary. So we get lots of information. The thing that we're interested in is the effect of education on the wage rate. And as you can see, the estimated coefficient of the effect of education on the wage rate is almost 0.5, and it's highly significant. It has a t-value above 9. So when you run this, you may see different numbers here because the data that we generated is random, so it differs from case to case. But you will also see that you find a positive effect of education on the wage rate, which is highly significant. And of course the point is, we generated the data ourselves and we know this effect is actually equal to 0. There is no effect of education on the wage rate that you earn. So OLS here basically gives us the wrong impression. It gives us a correlation, but it does not give us a causal effect. And the reason is, of course, that there is this variable u, motivation, which affects both education and the wage rate. So that generates a correlation between education and the wage rate, but there is no causal effect.